Hey everyone, right behind me is a mountain. And if you look at the side of that mountain, it has a straight side that can be described using a linear equation. This linear equation can give us some more information about that side of the mountain. For example, I would want to know how steep is the side of that mountain. In this video, I'm going to show you how we can calculate the slope of the side of a mountain just like the one behind me. So pay attention and I'm going to show you how. Now, if you know how to calculate the slope of a line and you want to know how to use that slope and the intercept of that line to figure out the linear equation of a line, then click on this link up here to watch the second part of this series. On the other hand, if you want to figure out how to get the linear equation of parallel lines or perpendicular lines, which is a bit more challenging, then click on the link up here to watch the third part of the series. Otherwise, keep watching this video and I'm going to show you how you can calculate the slope of a line. My name is Peter. Grab your calculator and let's get started. So when it comes to linear equations, we want to examine the properties of graphs with straight lines. In this particular video, whenever I mention linear, I'm going to be specifically referring to straight lines. So we're going to distinguish how they look like graphically. Below here, I have an example of a linear equation and it just shows a straight line. Non-linear equations, on the other hand, are not straight. So both of these are non-linear equations. The main idea behind today's video is to figure out what information does the equation of a line give you. One piece of information that the line gives you is the slope of a line. With the slope, we can determine the direction and amount of gradient in the line. So on this slide, we have three pictures depicting the magnitude of slope. The first image here shows a very steep side of a mountain. The second image, a flat road. And the third image shows a staircase. Pretty easy for you to go up and down that staircase. So we can think of a slope as how steep a line is. Here's a formal definition of a slope of a line, and it says the slope m of a line represents the constant rate of change of a linear function. So in this video, I'm going to be using the letter m to represent that slope. The other important thing is the use of the word constant. This means that the slope that we'll be calculating will not change wherever we are on the line. Finally, the slope in this video is going to be calculated from a straight line. Here's the formula that says slope equals to the vertical change divided by the horizontal change. So in this formula, these two calculations are not interchangeable. Vertical change has to be in the numerator, horizontal change has to be in the denominator. Now, if you have 2 points on a line, x1, y1, that is up here, and x2, y2, that's down here, you can use those 2 points on the line to calculate the slope of that line simply by subtracting the y coordinates in the numerator and then divide by the difference of the x coordinates in the denominator. How do we find the slope of a line? There are two ways that we can do this. Either we're going to use 2 points on the line, and this is usually an easier and faster method, or you can be given a graph and then you need to find the slope. This is slightly harder and longer because it requires a few more steps. We're gonna go through each of these two scenarios using examples, and you're gonna see how just easy it is to find the slope of a line. Here are a couple of examples that we're gonna go through involving how to find the slope from 2 points. So the first 2 points that we have here are 19, -16, -7, -15. We're going to use our formula m equals to, so instead of writing the word slope, we're going to be using this letter m here to signify or represent slope, equals to the difference of the y values. So we have -16 minus 15. Notice I'm putting this -15 inside parentheses so that that -15 is not confused with the minus sign. And then in the denominator, we have 19 minus 7. And I'm doing the same thing in the denominator, where the -7 is not going to be confused with the minus sign. In the numerator, when you have two negative signs here, they combine to make a plus sign. So we're going to have -16 plus 15. And in the denominator, we're going to have 19 plus 7. When you add -16 plus 15, it's -1. 19 plus 7 is 26. The second example, we're going to go through the same process, starting off with m equals to the vertical change, it's going to be 8 minus 16, and the horizontal change is 20 minus 9. 8 minus 16 is negative 8, and 20 minus 9 is positive 11. This fraction here cannot be simplified, so this is the final solution. In the last example, we're going to subtract negative 13 minus 8 in the numerator, and in the denominator we have 17 minus 17. Negative 13 minus 8 is negative 21, and in the denominator we're going to have a 0. So in mathematics you cannot divide by 0, so the slope in this case is described as undefined. Let's work on two more examples. And the first example, we're going to use the same formula that we've been using before. So we're going to subtract 18 minus 18, divide by 12 minus 15. In both of these calculations, I'm using parentheses so that we don't confuse the negative sign and the minus sign. So in the numerator, when you combine the two negative signs, you're going to have 18 plus 18. And in the denominator, when you combine the two negative signs, you have 12 plus 15. In the numerator, you're going to get 0, and in the denominator, 27. If you divide by 27, that simplifies to 0. The slope of this line that is passing through these 2 points is 0. The second calculation is m equals to negative 20 minus 8 divided by 3 minus 5. Negative 20 minus 8 is negative 28. 3 minus 5 is negative 2. And you need to simplify this fraction. So when you divide those two numbers, you'll get positive 14. From the calculations that we've just done, we can summarize that there are only 4 types of slopes. There's positive slopes, negative slopes, zero slopes, and undefined slopes. For you to have a positive slope, the line needs to be increasing from left to right. Negative slopes always decrease from left to right. Zero slopes are horizontal lines. Undefined slopes are vertical lines. Let's now figure out how to find the slope of a line when you're given a graph. Using the information that we've just learned about the 4 types of slopes, in this first graph, we see that the line is increasing from left to right. It has a positive slope. After we do the calculations, the numerical value should be positive. So let's go through the calculation. The first thing is to determine those 2 points that are marked on the line. The first point is 0, 0, the origin, and the second point here is 2, 1. When we put those values in the formula, m equals to the vertical change 1 minus 0 divided by the horizontal change 2 minus 0 is equal to 1 divided by 2. 1/2 is positive, and that matches the answer that we had at the beginning, that this line has a positive slope. Let's take a look at the second math problem. The second math problem has a line that is decreasing from left to right. So the final answer should be a negative number. Let's go through the calculations. The first point there is negative 4, positive 1. The second point there is negative 2, negative 1. So when we put these 2 points in the formula, we have 1 minus 1 and negative 4 minus 2. In the numerator, the 2 negative signs are going to form a plus sign, and in the denominator, we're also going to have negative 4 plus 2. In the numerator, 1 plus 1 is 2, and in the denominator, we have negative 2. When you divide those two numbers, 2 divided by negative 2, you get negative 1. Our final answer matches our initial answer, which was this graph here has a negative slope. Let's continue finding the slopes using a graph. And in these 2 examples, they're slightly different from the 2 graphs that we saw before. In these 2 graphs, we can see that we don't have the points already indicated. So we have to actually do a little bit more work in these 2 examples. We have to figure out 2 points on this line. Those 2 points have to be easy for us to identify the x and the y value. Now, if you look along this blue line, there are some points that are not quite easy for us to figure out the x and y. For example, this point here, it's hard for us to know what is exactly the x value, what's the exact y value. But if you look at this other point here, we can know exactly what the x value is and the y value. Now, we need one more point. So we're going to go down the line until we reach reach this other point here, and we can see the exact x value and the exact y value. So let's write down those two coordinates. The first one is 0, 1, and the second one is 4, -4. Now that we have our 2 points, now we need to figure out what type of slope is this. This line here is decreasing from left to right. That means this is a negative slope. In our final answer, we should get a negative slope. So let's go ahead and calculate the slope. M is equal to 1 minus 4, that's the vertical change, and 0 minus 4, which is the horizontal change. In the numerator, those two negative signs combine to make a positive, so 1 plus 4, and in the denominator, we just get -4. In the numerator, when you add those two numbers, you get a 5, and in the denominator, you remain with a -4. This fraction here is a negative number, so that confirms that the slope of this line is negative, which is 5 over -4. Second math problem, we see that we're also given a line, there are no 2 points, so we need to find 2 good points along the line. So starting here, I can see a really good point there, and we move along the line and I see another really good point here. So those are the 2 points that we're going to use. The first point there is 4, 3, and the second point there is 1, -1. We need to figure out what type of slope is this. Since it's increasing from left to right, this slope is positive. Our final answer should be a positive number. Let's calculate the slope. M equals to 3 minus 1 in the numerator, and in the denominator 4 minus 1. Because we have two negative signs, it's going to be 3 plus 1, and in the denominator 4 minus 1 is just a 3. 3 plus 1 is equal to 4, and in the denominator it's a 3. This fraction here is positive, and that confirms our slope here is a positive slope. Here's a quick pro tip. Every single straight line can be categorized under one of 4 groups. The first group is a positive slope, the second group is a negative slope, the third group is a 0 slope, and the fourth group is an undefined slope. Right before you start calculating the slope of a graph, look at the graph and try to determine what could be the final answer. If you see a graph that looks like this, even before you start calculating, you can figure out what the answer might be. This is a nice trick to help you avoid making mistakes at the end, and that's the pro tip. After going through several exercises, here's some independent exercises where you need to calculate the slope. The answers for these 3 exercises can be found in the description box below. Good luck!